Fantastic. Thanks for that intro, Fred. I appreciate it. Can everybody see the screen? This is my first time using GoToMeeting in a while, so bear with me here.
Looks good.
Yeah, we have
Great.
Yes, I can see it.
Excellent. Well, with that, I think Fred gave a great intro, so I'll just dive right in to talk about the exciting work that we've been able to do with Fred over the last few years. As Fred did mention, this was a partnership with Citrus College, Southern California Edison, SoCal Gas, and ourselves to drive retro-commissioning efforts at California community colleges. We executed a project in 3 phases over 5 years that included the central plant, as well as 12 of the largest buildings on campus. And this project was able to achieve over 1.5 million kilowatt hours of electric energy savings and 40,000 therms, representing about 11% reduction in the campus energy consumption, or about $225,000 in energy costs per year. And not only were we able to capture energy savings, but through this partnership with the utilities, Fred was able to capture a significant amount of utility incentives in the amount of over $400,000. And all this work was able to be done with payback of under 4 years. And I think as we go through the scope of what was completed and the different benefits that Citrus received, I think that is going to prove itself to be quite a deal. And the California Community Colleges Board of Governors Energy and Sustainability Award seems to agree. We were awarded with the Best Overall Innovative Project for a medium-sized community college district just earlier this year. So really proud of that, really proud of the partnership we've had with Fred over the years. He's been doing some really great things on his campus and for the community college system as a whole. So today I want to take you just briefly through what the retro commissioning, which we abbreviate as RCX, what that process is and how it works. I want to talk about some of the specific measures that we implemented at Fred's campus, Citrus, talk about some of the project results, and then how retro commissioning fits into some forward-thinking planning that you might be doing for your own campuses or cities or whatever institutions you are representing here. Now, before I do dive into the process, I can't help but share this slide kind of right up front, because this is something I'm really proud of, and I think Fred is probably as well. So this graph right here, just to explain it a little bit, the dark blue bars here represent the actual measured energy consumption, electric consumption of Citrus College from 2013 through 2018, which is the time frame when we executed our retro commissioning projects. The red line here shows the total campus square footage. So actually around 2016-17, Citrus built a new building and increased the square footage of their campus. And this light blue line in the bar here is showing if the campus had maintained the same energy intensity that they were operating at prior to our retro commissioning work, what the campus energy consumption would have been with that added square footage. And as you can see, even though the campus increased in size by about 5%, we were able to achieve an overall reduction in energy consumption of 7% compared to the previous baseline, or around 10 or 15% compared to what would have been the case with that increased square footage. And we can see the different projects that were executed here. So this was the first phase, our central plant retro commissioning, which dropped the energy intensity of the campus immediately in 2015. We did our phase 2 retro commissioning after that, right in line with when the building was added, and then phase 3 in 2018. So we had a consistent and regular downward trend in energy consumption, even though the campus square footage increased. And I was talking to Fred the other day, and he also mentioned that I believe you said there was like a 10 or 15% increase in your electric rates over the same time frame. And despite that increase in rates, you have not experienced an increase in your total energy cost, in part due to these continued reductions of retro commissioning that you've been
That's correct.
over the years. So really great way to keep costs in line, prevent creep of energy costs over time. And if you are looking at your energy data and you see that number going up and up and up over the years, then that's a really good indicator that retro commissioning might be for you. So with that said, I will take you briefly through kind of a high level of what the process looks like in a bit of a flow chart here, and then we'll get into some of the specifics. So the way I like to think about retro commissioning and projects in general is kind of asking myself certain questions. So the first question we're really trying to ask as part of this process is, how should your building operate? So what is the design intent? And we look at building drawings, sequences of operations, manufacturer's specifications to understand what the design intent of the building is. And similarly, you might have current facility requirements that have changed since the building was designed. And we're really looking to identify any key differences there between what your current facility needs are versus what the original design intent was. And there's often opportunity to optimize your current facility requirements versus the design. Now, additionally, we also like to then ask, so how is the building currently operating, or campus of buildings? So we want to verify the current operational conditions. So that process will often use utility data, trend data from your building management system, and physical on-site review of systems to determine if your current system operations are actually in line with your facility requirements and the design intent. And again, we want to ask ourselves, are there any key differences between what's currently happening versus how the buildings were designed? And really, those key differences is what drives optimization. So if we've identified that the current building is operating poorly compared to the design intent, then we can identify opportunities to optimize and restore the building to how it's intended to be run. And often that will lead to energy savings, that will lead to improved occupant comfort, better equipment longevity, and more importantly lately, occupant safety through maintaining proper ventilation in particular, and temperature control of the space. So this whole process, we apply through our engineering investigations, and the end result at the investigation phase is typically a report of our findings. Here's kind of a snippet of one measure from our phase 3 report with Citrus. This was a measure to adjust the supply air temperature control for the air handlers of a subset of their buildings. The air temperature had been fixed temperature before, and we were recommending a supply air temperature reset, which some of you may have heard of before. And so our goal here is really to identify and clearly communicate the problem to Fred and the other building operators who are making these decisions, as well as communicate the potential savings and costs and cost effectiveness of that measure. Now, in addition to identifying the problem, we also want to identify our proposed solution. And I think this is really where you'll see a big variety in terms of quality of audit reports or retro commissioning reports, et cetera. Some might say our recommended solution is to implement a supplier temperature reset and vary the supplier temperature and leave it at that. And that's all well and good, but what it's really not is it's not actionable and it's not biddable, because the devil's really in the details in terms of what is actually going to be required to implement a project. And so one thing we really tried to focus on with this effort was to step-by-step lay out what's really required for the project, so that the controls contractor or mechanical provider, whoever is going to be actually executing the work, in this case it was Climatech control contractor, they can have a very specific step-by-step process. So check the calibration of the sensors, repair if needed, implement the specific sequence based on various inputs and outputs from the control system. And this gives us a pathway to the bid and also a good reference to go back and look at when bids come in and we're trying to compare different solutions. We can make sure that everybody is providing the same services and is adhering to a specific scope that's been laid out. So this is just a snippet of a report. The overall report will typically begin with really what ends up being, in most cases, one of the most important things, which is the overall financials of the project. So here is a sample summary from the first project we did with Fred, which was the central plant retro-commissioning. So we have a number of different RCX measures listed out here, from some pump control, some boiler efficiency upgrades, some adjustment to the thermal energy storage sequences. We have our calculated energy savings, cost savings, and then again here, this estimated measure cost. This is always a tough one to dial in, and this is where having that really detailed scope and recommendation is going to help dial those costs in as closely as possible. And as you can see from this project, we had a very favorable 1.2-year payback once the generous incentives from the utilities were factored into the project. Although in this case, I think the payback would have been pretty attractive with or without the incentives, as is often the case with retro commissioning. These are, the goal is operational adjustments, controls, tweaks. So these often end up being the most cost-effective opportunities for energy savings, especially when compared to equipment replacements or adding, generation and things like that. And we'll get into that a little bit later as well. So once the case is made for the project, the savings are there, we get the go-ahead. With Fred, we were able to participate in the implementation as well, which is an excellent feature. So we were able to work with the controls contractor and guide them through the process. And then typically after the project is implemented, there is a final phase where we do the verification. And really this final phase is meant to determine whether or not we've succeeded in our mission to optimize systems back to their design intent. So here is again the flowchart of the retro commissioning process that I presented before. And essentially in the verification phase, we are doing the same process. We have now updated the current facility requirements based on what we've seen and investigated from the building. We've attempted to optimize systems to align that, and now we want to look at data to track the energy consumption, track the system level operation to confirm whether or not we've succeeded in aligning the current operations with the design intent or current requirements. So this last step can take on a number of different forms, and that has been changing quite a bit over the years. In the past, this was often a couple weeks of trend data after the project. We verify that things are looking good. We verify the savings, and then that's the end of the project. More and more these days, especially with lots of push towards ongoing management and different tools that are available, we're looking more at a monitoring-based commissioning effort, which is what this MBCX down here stands for. And there's a lot of tools out there, SkySpark, different energy management tools that are being used to continually track energy consumption and system operations over time, and continually updating this question of how am I doing compared to the design intent. And in some cases with some of these tools, it can throw up automated flags of fault detection to indicate when systems are falling out of calibration and might need some further attention. So really the purpose here is to confirm that systems have been updated and are running properly at the completion of a project. And then ideally through various tracking procedures over time, you're going to continually check that question against itself and make sure that you're not slipping back into malfunctioning systems as time marches on. So that's the general process. It was a very quick explanation of the process, and we didn't say beforehand, but if there are any questions, you're welcome to add them to chat or jump in anytime. I think Connie was going to review those and let me know if anything comes up. And if not, I will continue marching on. The next item I wanted to talk about was some of the specific projects that we were able to complete with Citrus and with Fred, ranging from both the central plant and the building projects that we did. And specifically, I want to focus on a few of the measures that not only saved energy, which is always our goal as energy engineers, but what often makes for the most impactful and effective measure is something that's going to have energy savings and an additional effect that can often be equally as important, if not more important, to some stakeholders than the energy savings alone. So here's a graph of Citrus College's primary chilled water pumps. This was a graph that we collected prior to our first retro commissioning project. And what you can see here is the pumps are operating during the day when the chiller plant is on at about 8.8 kW up at the top. That's that nice flat solid line at the top. But then when the system is off at night, the chillers are off, and actually what we saw in the data was that the pumps, which should have also been off, were cycling rapidly. And this is obviously causing excess energy consumption because the pumps are turning off, on, and running. But also this very rapid cycling on and off is not good at all for the integrity of the variable frequency drive, which these pumps had, nor is it good for the motor itself. So had these pumps continued to run this way for a longer period of time, it likely would have led to premature failure of either the drive or the pumps, not to mention the excess energy consumption. So as part of the retro commissioning process, we identified this issue. We then identified that the intention was for these pumps to be running at a constant flow during the day, but that they should be off at night. And then we identified the issue in the control sequences. There was a faulty signal from the sequences that was causing these pumps to come on at night. And we also had balancing valves that were partially closed down, which were causing elevated consumption during the day. So having identified that issue, we then worked with Climatech to correct that issue through simple changes to the control sequences. And the end result was that during the day after the project, the pumps were no longer operating at 8.8 kW. They were hovering down at 6.5 kW during the day. And the cycling was completely eliminated from overnight operation. So not only did we achieve energy savings, both in the off period and the operating period, but we believe we significantly extended the life of these pumps through this project by eliminating that really rough cycling that was previously experienced. So there's also energy savings and improved occupant comfort, not just equipment integrity. So here's another example of the math and science building. Here's a few of the zone temperatures that we were looking at in the building, and you can see circled in red here that we've got some problems. There's 2 rooms here that are over 78 degrees, certainly outside of the comfort range for a typical building in this climate, and possibly even more importantly, out of certain recommended ranges by ASHRAE for occupant safety now. And then another room here was showing negative 0.7 degrees, which is hopefully or obviously not correct, but indicates that that sensor is not working. So these can cause energy problems if this is causing excess heating, if the sensor is bad, or if a zone like this is driving cooling supplier temperature resets. but it's also a comfort issue. Obviously, if these zone temperatures are accurate, which we verified they were, then the occupants in these areas are likely not going to be comfortable. And that results in excess hot and cold calls that go to the facility staff and bog down their otherwise already very busy workflow with additional nuisance requests. So again, as part of the project, we identified this deficiency compared to how these systems were supposed to be running. We worked again with Climatech to identify the root cause, which was some bad sensors and control data throughout the space, and corrected it as part of the final project. And you can see in this post-retrofit data that the proper signal from this room has been restored, and the temperatures have been brought down in line with the rest of the building, as well as the typical comfort range. And so we've achieved with this project energy savings, as well as improved occupant comfort, and hopefully some reduced burden on the maintenance staff through less hot and cold calls. And the last one I really want to talk about in detail here, and it's especially important these days, I think, is the component of occupant safety, as well as energy savings benefit. So here we have a graph on the left of the outside air dampers of a few of the air handlers at student services and library and life sciences at Citrus College. This graph indicates that these outside air dampers are stuck open. So we can see that as the outside air temperature changes, the mixed air temperature is changing in exactly a linear fashion with that outside air temperature, which means that no air is recirculating back from the zone, and it's just fully 100% outside air unit. Now, in terms of ventilation, that's great. That's maximum fresh air for the occupants. But once you start getting up into these 80, 90 degree ranges, it's very likely that your cooling system is not designed for that type of outdoor air temperature at 100% outside air flow. And as a result, it's likely that your zones are not going to be able to maintain their temperature set points. And similarly, at the low end down here, once we get down into the 40s and below, bringing in 100% outside air is going to make it impossible to keep those spaces warm in these temperature ranges. So there's an issue with maintaining heating and cooling set points, and there's a large burden on the energy consumption of the heating and cooling systems as a result. Now, similarly, at the same time, and in some cases on the same buildings, we had other units that had their outside air dampers stuck completely closed. So you can see that again here from the graph. As the outside air temperature is changing throughout the course of our data collection period, there was really no associated change in the mixed air temperature. And in particular, in these mild conditions where we would expect the economizer to be functioning at full outside air mode and opening up fully to minimize the cooling consumption, we don't see any of that relationship similar to what we see here in this data. So the outside air damper being stuck closed, that's actually going to help with the heating and cooling loads maybe at these extreme temperatures. But as we're all well aware of right now, ventilation is very important. And having these dampers stuck closed essentially means that the occupants in these areas that are served by the air handlers are not getting the outside airflow rate that is intended and required by the design of the system. And especially now, that is a strong concern with COVID and other general air quality concerns that are front of mind lately. So in correcting both of these issues, we were able to save energy by fixing the ones that are stuck open. We were able to save energy on the high end of the cooling range and the low end of the heating range. And by fixing the ones that were stuck closed, we were able to save energy in this mild range when we would rather have them fully open. And in both cases, we were able to improve the indoor conditions for temperature control as well as ventilation. And I think one of the real takeaways I'd like to relay here is that we've gotten a lot of questions lately, again, with the current environment, trying to reopen buildings amidst the ongoing and hopefully dwindling pandemic, of people looking to install quite expensive and energy intensive equipment, UVC and bipolar ionization, things like that to purify the air, maybe looking to significantly increase outside airflow rates or install additional filtration. And there certainly is a time and place and necessity for those in some cases, but my strong recommendation would be to make sure that you have evaluated your existing systems first. Make sure you don't have these types of issues that represent low-hanging fruit to significantly improve your occupant safety through ventilation and temperature control, and at the same time will actually yield energy and cost savings to you as opposed to significant additional capital cost and operational cost by adding these additional air purification and filtration systems. So to summarize the effort that we went through and the overall project benefits that I think Fred can attest to, we did a number of projects at a large swath of his buildings, including the central plant. Fred was able to upgrade his old BMS controllers and hardware to brand new equipment that should be highly functional for years to come. There was a significant reduction in the burden on his maintenance team, especially at the central plant. There was a lot of manual control of the thermal energy storage discharge and charging cycle before this. That has been fully optimized and automated as part of this process. He's gotten better tools to maintain building comfort and be alerted when building comfort is not being maintained. Improved reliability and longevity of his mechanical equipment. A boatload of incentive dollars for the project, which certainly helped the bottom line. And on top of those incentive dollars, some strong recurring energy savings that, as I mentioned previously, are really helping to offset the impact of not only increased square footage and footprint of the campus, but ever increasing energy costs and energy rates from the utility. And all of these benefits come at quite an attractive payback. I showed the central plant project, which had just over a year payback, and the other projects came in with similarly competitive paybacks for an overall payback of under 4 years, with benefits that I believe will outweigh that for a long time to come. And then for a bit, I just wanted to touch on how retro commissioning fits into some of the forward-thinking planning that you all might be considering in operating your facilities. This retro commissioning process has been around for quite some time, with varying levels of interest and impact. But I think it's really coming into its own now in terms of being really one of the most cost-effective ways to get your building in line, get it up to date with current requirements, both from Title 24 and ASHRAE, et cetera. And specifically, my first item here in terms of COVID reopening, as I mentioned, in my opinion, RCX is one of the very first things you should do when looking at the pathway to reopening buildings. It's also one of the first steps that ASHRAE recommends in their publicly available information about reopening. And in ASHRAE's entire list of recommendations, which includes increased filtration, increased air change rates, and possible additional purification, it is literally the only one of their recommendations that could actually reduce your operational costs and have an actual payback, as opposed to the other recommendations, which, while important to maintaining occupant comfort, are also perfectly capable of skyrocketing your energy costs if they are not implemented in a way that is considerate of the entire system's operation as a whole. There's also been a lot of push lately for zero net energy design and operation of buildings. And with a lot of clients that come to us, the way they think about ZNE is that, well, we just have to add generation to cover our current consumption and we're a ZNE building. And in many cases, that's true. If you have enough roof area, you could potentially install enough solar to offset your whole cost and consider your building ZNE. But I definitely encourage folks to think about that process of achieving zero net energy in a more sequential basis of minimizing your energy consumption first, and then seeking to offset the remainder of that consumption with generation. So taking the project with Citrus, for example, the cost to Citrus for each kilowatt hour of annual energy savings was 80 cents per annual kilowatt hour saved. Now, if we installed PV to similarly try to achieve that same amount of annual kilowatt hour savings, that would have been $24 per annual kWh saved. Plus, there's increased O&M cost for those panels. You have to make sure they're well maintained, they're cleaned, the inverter remains in good condition. So there is a huge benefit to reviewing your current operations, making sure everything is dialed in as well as it can be on the controls and operational side first. The other step between RCX and installing generation would be some potential retrofits as well, which would likely come in somewhere between the very cost-effective retro commissioning and the high-cost solar PV. But ultimately, the approach of trying to bring down your energy consumption first to right size and minimize the cost of the generation you need to install is going to be critical to being able to try to cost effectively achieve this ZNE design that so many are clamoring for these days. And really all of that can kind of go into and be summed up in a strong sustainability plan. That is a great method to really organize your goals and your methods of achieving your sustainability goals and provide accountability of who is responsible for what, and make sure that all of those missions and goals are publicly available to anybody who wants to see it. It really shows a commitment to issues that are becoming increasingly important to students, to building occupants, and to constituents, whether you're running a school or a commercial building or municipal facilities. There are stakeholders seemingly in every one of those arenas that are becoming more and more focused on sustainability, and RCX can really provide the first step and foundation for a strong sustainability plan. And Fred has shared Citrus's sustainability plan with me. I've looked through it, and it's got a really great format, good comprehensive information, lays out responsibilities and tasks. And I believe, Fred, correct me if I'm wrong, but you mentioned you could potentially share that for folks who might want to see it as an example for what they could put together if they're interested in developing that sort of long-term planning. Great. Well, that's the end of the prepared remarks I have, and I'd be happy to open it up to discussion of the project itself or the process or anything folks would like to talk about today.
We have any hands up, Connie? Yeah. So
no, not yet.
While we're getting some hands, one of the things that I would like to tell everybody is the retro commissioning projects are very, very difficult to do. If you think about your electrical bill that you get from Edison, we all pay into an account that is used, it's mandated by the Public Utilities Commission. And all the money goes into, a larger pot. And then what the Public Utilities Commission mandates is that the utilities, for us in our area, it's going to be SoCal Gas and Southern California Edison predominantly. But anyway, they're mandated that those utility organizations have to get rid of the money that's in that large pot in the form of incentives. And the theory behind it is California is reducing the generation of non-green technology. So, the nuclear power plants, gas-fired plants, all that kind of stuff. They don't like them. Everybody remembers, what it's been a couple of years now, maybe a little bit more, that San Onofre was actually taken offline and shut down. When they do that, the only way that we make up for that reduction of generation is through efficiency. That is the primary purpose of the mandate by the Public Utilities Commission for the utilities to put that money out there to create efficiency measures so that California doesn't go black. With all that being said, retrocommissioning was very difficult. And one of the things that we had to do, David talked about the measurement and verification. He showed you the slides on how we corrected those energy inefficient measures with something that was efficient. Just a little caveat to that, because we were so successful on RCX1, that's what actually led to RCX2 and then on to RCX3. But the amazing thing is once we did all the measurement and verification, about a year and a half after the fact, for our first project, I got an email from an energy engineer out of Massachusetts. And lo and behold, his firm was actually hired by the California Public Utilities Commission to come out and do a reconciliation on our RCX1. So, I knew we were getting put to the test. They're going to come out and check and see if we kept everything that we said that we were going to do, if we in fact kept it in place. So we scheduled an appointment. They actually made a physical visit. They came out, they were there for a few days. They actually downloaded a bunch of trend data and trend history off of our EMS system. And it turned out to be gigabyte after gigabyte after gigabyte of downloading. They took all that information back, looked at all the measures that we said that we were going to do. They went through all the buildings that were affected. And about 4 or 5 months after they collected all that data, I got a report from them. And the letter basically said that it was absolutely glowing. You guys did everything that you said you were going to do. You did not change a single thing, meaning we didn't go back there and change a set point from 72 and move it down to 65 in order to make somebody in a building happy that's getting the sweats all the time. We kept everything in place, and they were elated about that. So that in turn led to many other community colleges in the system being allowed to do retrocommissioning on their campus as well. And then it allowed us to do RCX number 2. About a year after a fact, the exact same thing happened again. They came out, went through all my books, all of the trend data, downloaded gigabytes of more information, went back, and we got another glowing report. So Edison was very, very proud of the work that our team did on our campus, which includes Climatech as the implementation contractor, KW Engineering as the primary energy engineer, and then of course us with being a viable team member with them. That's what led to, getting checks for hundreds of thousands of dollars. How can you turn that down? And then when you look at payback times of a little over a year to a little bit less than 4 years on a significant investment like that, that's what I call a real bargain. And, everybody else on campus was happy with that. Those types of things are written into our sustainability plan, and we share it with the community. It's something that not only our campus can be proud of, but the entire community college system as a, on a grand scale. And I think that because of all of that, that's why we were awarded the award this year from the Board of Governors for Sustainability Champion. So, David, hats off to you. You and Arik played a tremendous role in that, and that's why we invite you guys out to tell all the good things that you did and be able to brag about your firm, because you most certainly deserve it 100%.
Well, I appreciate that, Frank, and the feelings mutual. Sorry, the real issue that we often face is finding a champion on site. There's often maybe one person who's interested in the project, and we work with them, and then it's like pulling teeth trying to get buy-in from everybody else on the campus. That is often something that can really stand in the way of the project. And Fred, your leadership and drive to get this stuff done, keep the projects moving along, and clearly to make sure that the changes were maintained and continued over time, with that last step that I mentioned of continually reviewing and making sure that everything's still in line is the key to success, and the key to actually maintaining the savings and getting your effective payback. And so it was certainly a pleasure, and I think
David,
well-deserved award, and people can learn tons from the effort.
Hey, David, there's a question on the chat line there from David.
Okay, let me see if I can find the chat line here.
Okay, it's what other companies or agencies is KW Engineering working with right now?
Well, we are working with quite a few different agencies. We do a lot of work with utilities still, and their programs for various users, including other schools, K-12, and higher education. We are one of the prime consultants with the Energy Network, SoCal REN, and they are leading a lot of municipal projects for energy efficiency and on-site generation and energy storage as well. And then we have quite a few private clients, some large companies, especially up in Silicon Valley area, who have their own internal programs similar to this effort, where they're less reliant on outside sources of funding, and they are driving this type of work forward just to achieve the energy payback and the improvements to occupant well-being and comfort that come along with these efforts.
Dave, you've done a great job, and we really appreciate what you've shown. We have on our group today, we have a dean from Norco College that has been very supportive of us. We appreciate him spending his time today. If there was an opportunity to get in front of their students,